morning, ladies and gentlemen. Thank you for attending our improving talk. We are thrilled you are spending some of your Wednesday with us. Before introducing our brilliant presenter, I wanted to ensure that our audience knows about the Q&A feature included in this webinar. If you have questions for the presenter, feel free to share in the Q&A feature, which is located at the bottom of the window. Your questions will be delivered to our insightful presenter at the final of the presentation. Speaking of insightful presenters, let me present Tom Buxton, who is a data science with Improving, working out of the Calgary, Canada office. He currently works remotely as a platform engineer with the Friedkin Group in Houston, Texas. Tom has a diverse background spanning oil and gas exploration, IT business consulting, software application, architecture, data management, and data science. Tom describes himself as a writer, photographer, canoe tripper, woodworker, fisherman, data science, and observer of life. The exact order can vary. He lives in Calgary with his partner Hitomi and cat Ryoma. Welcome and thank you. And the floor is all yours, Tom.
Thank you very much, Maurice. Much appreciated, and welcome everybody. As Maurice told you, my name is Tom Buxton, and I'm going to be your guide through this journey on the bricks within Databricks. The objective of this presentation is not really to provide a comparison of Databricks with other tools or to really go into any depth about the actual features it has. We will talk about that at some level, though. As an overview, Databricks is a multi-cloud based unified open analytics platform for building, deploying, sharing, and maintaining enterprise-grade data, analytics, and AI solutions at scale. Many of us have probably used the platform, but we may not have really considered about the pieces that go together under the hood in order to make the different components work. And that's going to be the focus of our talk. We're going to talk about the platform overview, a little bit about Databricks. We're going to introduce Unity Catalog at a very high level. We're going to talk about Databricks architecture, specifically in terms of AWS and how we access the underlying storage from Databricks, some of those components, how they work. We're then going to kind of pivot and talk about infrastructure as code. We're then going to talk about pipelines as code. Once we're done with that, we'll talk about just about what we've learned, just do a brief summary, and then we'll move on to any questions. I have a fair number of slides to cover, so I apologize, but I'm going to kind of move through the slide deck, and then if you can save your questions to the end, that'd be much appreciated. I did provide a glossary here that'll be available in the slide deck. I should think most of these terms are familiar to a lot of you. It's always hard with these talks to know exactly at what level to target them. This is going to be a fairly technical presentation covering a lot of ground. I will, to the best as I can, tell you what the acronyms are as we go. So without any more delay, let's move in and start talking about the Databricks platform as a whole. Databricks provides a platform that gives us data analytics, data science, data engineering, streaming and batch data processing all in one place. It was founded in 2013 by the team that developed Apache Spark. And since then, they've obviously continued to contribute not only with Databricks, but with Delta Lake and with MLflow. Databricks is a platform as a service solution hosted on top of a cloud-provided infrastructure as service cloud solution. It could be AWS, could be Azure, could be GCP. But in this presentation, we're going to talk about AWS. This is a Databricks slide, obviously. Just going to kind of hit some high-level pieces that we might want to talk about. Databricks gives us a Databricks AI, fairly new features over the last couple of years since LLMs have become more prevalent and available for this sort of functionality. At this year's Databricks Summit, they kind of introduced Genie Spaces, pretty exciting way of querying your data simply through regular text. You can just basically ask questions of your data, mostly get back an answer that makes sense. But it's going to transition us from a very dashboard environment into something more ad hoc, where we don't necessarily to provide a dashboard to answer those solutions. Quite exciting. Delta Live tables. This is for extract, transform, load ETL pipelines. Quite an efficient way of building those data pipelines. Workflows, where a lot of the work within Databricks gets done. And of course, kind of the beginning of all of this, Databricks SQL, basically a data warehouse that allows us to access and query our SQL. And now with, once again, with more general non-programming, non-SQL kind of queries. This is built on top of a Unity Catalog, which is a fine-grained integrated data governance catalog for both data and AI assets. We're going to talk about that a little bit later. And of course, built on top of Delta Lake. At the conference this year, Databricks announced their takeover of Tabular, which kind of changes the space around jockeying for position with Iceberg as far as a Delta Lake solution. We'll see where that ends up. But for now, Delta Lake gives us great functionality on top of what we might have used in the past as far as data warehousing. We're not going to talk about this hardly at all in this presentation, but regardless, it gives us an overview of what Databricks provides. I think the key takeaway, though, is Databricks is innovating and evolving fast, and even in the time frame of my current engagement, lots of things have changed. Unity Catalog. Unity Catalog is a unified open governance solution for data and AI built on the Databricks platform. Before Unity, we had to basically use the traditional Metastore, which was limited to a particular workspace. Now with Unity, we have user management and Metastore spanning workspaces, which is a huge step forward. Providing lineage, data discovery across our workspaces. Really high level. Metastore, beneath Metastore, we have catalog. Beneath catalog, we have schema. Sometimes schema is described as the database component that we might kind of rationalize with what we're familiar with standard SQL Server, this sort of thing. I don't necessarily agree with that. To me, the three-level namespace that Unity Catalog provides is very analogous to kind of like a database schema table that we're familiar with SQL Server. Tables, views, volumes, models, functions, all of these are entities underneath schema. Moving on, I'm going to move fairly fast. Hopefully someone will jog me if I'm being incomprehensible. So let's talk about Databricks architecture. Three main components really that we should be aware of. We have a control plane, which is hosted by Databricks within our Databricks account. This we have very little input into. It's where our users connect to the web application from. It's where Unity Catalog lives. Since serverless compute became a thing, we now have a serverless compute plane, which is also part of your Databricks account and wholly managed by Databricks. These pieces are linked into your AWS account. And this is really the premise of Databricks, is that your data and your compute is resident with your own cloud account, which we are responsible for controlling and securing. And that is linked into our resources such as S3 storage and EC2 compute, this sort of thing within AWS. Please ignore the numbers. They were for another purpose and bear no resemblance to what I've just been talking to. When we talk about compute in Databricks, basically we have a number of different types. We have general purpose compute, which could be shared or single user or service principal. We have job compute, which exists for the lifetime of a job, and serverless compute, which is I think the vision of Databricks for all compute moving forward, but it currently has been rolled out not just to classic SQL workflows, but now to jobs and pipelines and notebooks, this sort of thing. And we also have instance pools where we can kind of warm up compute in advance. When I say compute, this is the compute that's actually being used to do the work within Databricks. We should all hopefully be fairly familiar with that. Moving on. Quick look at the Databricks UI. A lot of us, I think, probably have seen this before as we log in and we do our work within Databricks. We don't see anything. None of the details of what goes under the hood really are available. As far as control plane or compute plane and things have any real bearing to what we see here. And basically, we just have tabs that give us access to our workspaces, catalogs, which is our access to the metastore, to Unity, workflows, compute, as we've just been discussing, SQL for making SQL queries to our data. And then data engineering, creating pipelines, that sort of thing, and machine learning, where we might create experiments or ML models and this sort of thing, right? So we're not going to talk about this beyond what we've just seen. Let's move on. So really the focus of this discussion is going to be around taking a business case and how we might implement that, not only in the architecture of Databricks, but also as code. And in our particular case, for the client that I've been working on, the pattern of a line of business architecture made a lot of sense. And when we say line of business, we're meaning something like product line or department or subsidiary within a particular organization. For myself, in this particular job that I'm working on now, we had subsidiaries. So for those, they needed to be totally isolated. And we also have a level beyond this as far as managing specific products or teams. And we do that using Unity Catalog, which we're going to talk about here today. So in this particular architecture, we have a single Databricks account, everything in the same region. So we use a single metastore, Unity Catalog metastore, and then each line of business is in its own cloud account. So for us, that's AWS. And then each of those has a development workspace, a staging or production or testing or QA workspace, whatever we want to call it. I'll call it testing. And then we also have a production workspace. So we have 3 workspaces within our Databricks line of business account for this particular line of business. And yeah, we might model those with a Unity catalog for all 3, but more likely, as we'll see in this presentation, we're going to use a catalog for each of those environments. Let's move on to the next slide. So there's a lot of bricks in Databricks, and what we're going to talk about in this presentation is kind of what cements them all together. Some of these terms I've talked about. We talked about control plane, but we haven't talked about, actually, we've talked about a lot of them. We haven't talked about IAM role, but anyway, we'll get to these later. So there's a lot here. To be honest, it gets pretty confusing. So I've asked my cat, Yoma, to give us a little bit of humor and keep us engaged in the presentation. But what we're going to talk about next is the fact that Databricks provides a huge amount of documentation, and it changes quickly, and it disappears, and it appears. There's an active community. We can get answers from questions there. And we also get support through enterprise accounts, which can be very helpful. However, the challenges are still such that sometimes it's hard to really know what these components look like under the hood, and it's hard to know what questions we should be answering or asking. So we found it really helpful to look at the architecture of Databricks with a object-oriented design lens. That is what we're going to do now. And first of all, we're going to talk about a class view. I do give a caveat here. This is our interpretation. This kind of comment down at the bottom. We have no privy into how Databricks has implemented their entities below the hood. But this is our approach to kind of help us understand how these pieces look together, because it's very helpful once we start actually building the infrastructure of the environment. So at the very top level, we have a Databricks account, we have a Unity Catalog metastore, and we have workspaces. And workspaces is where the actual work gets done. Databricks account is one level above that. And we've already talked in some detail about what the metastore provides. At the account level, we have a 0 or more metastores. To our interest here, though, we're all in the same region within AWS, so we have a single Unity Catalog metastore, and we have multiple workspaces. Within our metastore, we have 0 or more catalogs, like a composition relationship there, and each catalog has 0 or more schemas, and each schema has 0 or more tables, views, volumes, and functions, and other things that I haven't put on this diagram, but you get the idea of what we're doing. An incredibly important piece to understand here is that when we create our catalog, we have to bind our Unity Catalog metastore to our workspace, otherwise the workspace has no access to it. That makes sense. But more importantly, when we create our catalog, we create it as an isolated catalog in order to control access to which workspaces within the Databricks account have access to it. And that means that we have to explicitly bind the catalogs that we're interested in to our workspace. At the workspace level, we basically have clusters that we define within our workspace, and we also have S3 storage. Both clusters and S3 storage are tightly bound to our AWS account, which is providing the container, if you like, for our compute plane within Databricks that we've already talked about. That is what I want to talk about here. This slide is a horrible slide, and I apologize for that. I'm going to keep this description really at a very high level. It's useful for digging in and actually trying to understand what's going on, but I think for this presentation, I'm going to keep it really high level. Basically, we have a Databricks account, which we've already talked about. We have our 3 workspaces. This one's dev, this one's test, this one's prod. We have a Unity Catalog metastore, and we have 3 product teams, right? So this whole thing is a line of business, and within that, we have 3 product teams, and they might be working on different ML models. They might be working on different product lines, regardless. But we have a requirement within my current engagement to keep those isolated, and that's why not only are we providing a separate catalog for each environment, but we take that one step further and provide a separate catalog for each of these product teams within those environments. So this diagram is a little bit ambiguous because I'm doing the classic UML approach of trying to hide complexity and just provide the important details. This group here, which is a data scientist group, there is basically a separate group for each of these project teams in each of these environments. I'm really just trying to show you the example here to show how we take a group at the account level. We use identity federation to make it available within the workspace, and then we provide different grants on that on the Unity Catalog entities to that group. And those grants, as we see here in dev, might be read-write for the dev catalog, read for the test catalog, and read-only, obviously, for the prod catalog. Within the test environment, everything's read-only. Within the prod environment is read-only. But we're really only binding the catalogs to the environments for the higher level catalog. So for example, in test, we only bind the test catalog and the prod catalog to the test workspace. We're going to talk about that in a little bit more detail later. So that's all I'm going to talk about here. I apologize if that has left you reeling and confused, because it is a confusing diagram. I almost took it out. Anyway, so listen to the cat. The cat says, let's talk architecture. So let's kind of dig down a little bit more. First of all, let's talk about infrastructure, right? So in our particular case, we implemented the data exfiltration architecture, which is basically a hub and spoke architecture within AWS, leveraging the AWS networking components to provide an environment in which we're going to place our workspaces and our account for Databricks. Data exfiltration is basically the concern that we have about data within our environments being taken out without us knowing. And that can happen because somebody is stealing it, or it can happen by mistake. And we need to protect our client data against both of those actualities. So in this particular environment, we have a hub. This is basically an inspection and an egress control VPC, a virtual private cloud. And within that, we have a NAT gateway for the internal routing, and we have a firewall that controls what sites outside on the public internet, which is over here, that we have access to. So, for example, we allow access to PyPy for Python libraries and this sort of thing, but we might lock down a lot, if not everything else, or a lot of other sites there. The hub is connected to individual spokes. Each spoke represents the compute plane of one workspace. They're connected through transit gateway. I'm not going to go into the details here, but we basically have availability zones within our spoke. Usually there's at least 2 of those. There can be more. This is really where we run compute, and we can either connect to the underlying control plane through private link, or we can not do that because it's at a higher level of subscription within Databricks. So we might connect to control plane directly, but regardless, there are some security protocols in place to protect those particular connections. We build this using Terraform, which is kind of the classic HashiCorp product for providing infrastructure as code. We're going to talk about that a lot later on, so I'm not going to talk about that here. Moving on. Let's talk about our high-level architecture now within Databricks. This is kind of similar to what I showed in the object model. We have a single Databricks account here. We have a single metastore. We have workspace environments for dev, test, and prod. And we have corresponding catalogs for those environments. And those are storing data and metadata externally within our AWS account within a separate bucket for dev, test, and prod. And because in our use case, we have product teams, it's not enough just to kind of dump all that data within that bucket. We actually follow a good practice regardless, which is to have a root folder, which I'm calling PT here, which stands for product team rather ambiguously. And that's where we're going to be storing the data from the individual schemas within our isolated catalogs. Just to kind of talk about a point that I made earlier, our approach is that we bind the catalogs, dev, test, and prod, all of them to the dev workspace. Classic example there is I'm a developer. I need access to a production model in order to compare a new version of that I'm developing in dev. Of course, I need to be able to do A/B testing between those two models. That's why I need to bind my prod, test, and dev catalogs to my dev workspace. However, in test and prod way, we are doing everything using service principals, and we have almost no interaction from the users themselves. We only bind to higher environments. So from test, we bind to test and prod is just bound to prod. Everything in prod has to come from prod. There's no leakage other than the promotion pipelines through the dev, test, prod stack. There's no leakage of data or artifacts or code or whatever else from lower environments in prod. So that's high-level architecture. Let's kind of dig a little bit deeper and look at what that looks like at a kind of a medium level. And in this sense, we're still looking at our prod workspace. And this time we've kind of opened up our catalog. We still have 3 environments, but we're actually just showing the prod environment here. So once again, we've bound our workspace to our Unity Catalog metastore, and we've bound it to our catalog. Within our catalog, in this case, I have 5 schemas. We're going to see an example where we have more in a minute, but basically here I have a base schema, models, bronze, silver, and gold. And obviously bronze, silver, and gold follow the standard medallion architecture for a Delta Lake. Each one of those is storing its data not within the DBS S3 storage that is configured for every workspace, but we explicitly store that within in this case, within a prod bucket within AWS. We have our PT folder that we talked about before, but now you see how we elaborate on that. And within that, we basically have a folder for each of those schemas. And within that, we might have tables and volumes as well. And as an example, in base, we have a tables folder, which is going to have any of the tabular data that we might create within our base schema. But we also have folders ingest, output, and artifacts. And that's because in this particular example, we're not connecting directly to data for our client. We're basically just moving data into ingest. We're doing something with it within Databricks, and then we're outputting the products that we create to an output folder. Artifacts is just things like compute initialization scripts, that sort of stuff. The other key point here is I already mentioned when we create a catalog, we create a metastore, sorry, we choose not to create external storage for that metastore, but at the catalog level, we have to define storage, and that's why we have this catalog folder here, which is linked to the catalog within Unity Catalog. Okay. Low-level architecture, a little bit more detail. Some of this I'm not going to talk about. I'm going to talk about here in a minute. We're going to come back to identity and access management. So this stuff, just ignore for now. This is basically the same thing you've already seen. Here's my metastore. We've already seen that. In this case, now we have 6 schemas because this is a dev environment. And the only thing we've added is a temp schema, which has tables and volume for the data scientists just as a play area. So they can kind of create things in here, play around with them, and in POCs, this sort of stuff, and then only move them into say, the model schema or something later on, once they're confident that this is something that could potentially get promoted. The thing I want to talk about here is we've added in this concept of functional groups. Functional groups, we have a reader and a writer at each level of our line of business, project team, and environment stack, if you like. And we have 2 groups that we assign to each schema. There's a read and a write group. At this level, we just assign the groups. We're going to talk later about how we actually assign users to them. So don't worry about whether somebody should have access into gold, for example. Of course, we want to prevent that at the right level, but we'll do that through the role groups we'll talk about in a minute. Okay, so that's kind of where we're on. So once again, Kat tells us to focus on access to storage, because I kind of glossed over that in the last slide. So let's kind of take a look at access to storage in Unity Catalog. And in this particular case, I'm going to introduce these new concepts now. We have a IAM role within AWS, which is tied specifically to a bucket at the bucket level. And that is done through a trust policy here, which is also providing the external ID for the assume role, so that basically Unity Catalog within Databricks can become this role and then access the underlying storage. We do this at the bucket level, not at the folder level. This role has a permissions policy and the bucket has a bucket policy, both of which provide read-write access and execute access and things to this role. The bucket policy, in addition, might provide access to external users or groups who might need to be able to write into the ingest folder, for example, or write or read data out of the export folder, right? So we control that through our bucket policy. Within Databricks, we have a new concept now that we're introducing called storage credential, and then a second one we're going to introduce, which is the external location. Both of these are actually Unity Catalog objects. They're not workspace objects, even though through the REST API we create them at the workspace level, so it's a little bit confusing. We can help that by using an admin workspace to create them. But at this level, I'm just showing them within the workspace because that's effectively how we interact with them within Databricks. And the way this works is the storage credential references the IAM role within AWS, and the external location references both the storage credential for that access permission and also the path to the underlying folder. Now, we can make things simple for ourselves, relatively speaking, by using an external location that kind of just maps to this upper level PT folder, our project team folder within external storage. And then when we define a specific storage route for a schema, in this case base, we kind of reference this one, which is part of the storage credential, but also tag in the subfolders that we need. So in this case, the Databricks will understand that this storage route is going to be handled by this external location and this storage credential, but specifically it's locking down access to specific subfolders base tables. And we do the same for volumes and everything else. And this is really how we can generalize at a high level as far as a role and a storage credential, at a slightly more detailed level as far as our external location, and then provide very fine-grained access to specific folders within our S3 storage within our particular schemas, or even at the tables level if we wish to. I mean, we certainly do it at the volumes level, but also we can do that at tables too. Okay, so a fair lot of detail there. Okay, let's dig into the weeds. Once again, we've already dealt with most of this. I mean, this is the beauty of UML, is we can, abstract away a lot of the complications and look at it at a high level. And we've kind of descended down through the stack. Now we're in the weeds. You can imagine this diagram is a mess if we start to look at multiple developed environments. Once again, here, I'm just looking at a dev workspace. I'm just looking at the dev catalog, and I'm just looking at my dev storage within AWS. The piece that we are adding in here, which I want to talk about, is here are our functional groups that we've already talked about, but now we're introducing the concept of a role group. And a role group is something like a data scientist group or a data engineer group or a data analyst group. And these are where the actual work is going to get done. So because we're in dev, we're actually assigning this group to almost all of these well, in fact, all of these functional groups, but that will not be the case in higher environments, right? We do not need to provide users with write access to test or write access to prod. That will all be done with service principals and through our promotion pipelines. So the details of who has access to what are handled within the Databricks account, which are based by who we assign our role group here to these individual functional groups. We have another role group here, which is the one that's handled by our external identity provider, in this case, Okta, and that is managed with individual users out of Active Directory within the client's network. They are assigned to Okta group. We sync the Okta group to the Databricks account through SCIM, which is a system for cross-domain identity management. We seem to have lost some letters there. I'm not sure how, but anyway, SCIM is our acronym. And this is going to allow us, through identity federation, to now take these users who really we know nothing about in Databricks other than that we brought them in through SCIM, and assign them to our groups. And then this whole kit and caboodle gets federated into our workspace just by assigning our functional groups to our workspace. Okay, so lots of information there, trying to keep it encapsulated so that we can focus on one thing at a time. I hope I've managed that. Okay, always listen to the cat. Right, so the cat asks an incredibly important question here, which is, life's too short to configure this by hand. When am I going to sleep? Good question. So there's a lot of moving parts. We've talked about that. We've glossed over a lot, but this is all really for one particular environment. When we start to have to configure this for the three environments, Databricks environments, multiple lines of business, that's a job that is going to require meticulous attention to detail, and we're all going to fail. So with that in mind, that's why we want to use infrastructure as code as a way of managing this process, and that is what we are going to talk about next. So let's talk about infrastructure as code. In this particular case, we're using it as a way of generating our architecture and our infrastructure consistently the same way every time in the same order, so that basically, in our case, we have an ephemeral environment. We want to be able to delete and rebuild these environments on a weekly basis. We're not there yet, but we are on track to being able to do that. We use a couple of different tools for our IAC work. We are using Terraform, and we're using Databricks CLI and Python SDK. So the handoff between those is for Terraform, it's building our hub and stroke infrastructure that we talked about already. It builds the IAM roles and policies, the S3 buckets. It builds the workspaces, and it builds the account components such as the functional groups, the role groups, service principals, and database secrets. The handoff is then to the Databricks CLI. We actually use the CLI because the SDK was in public preview when we started this work. We would not do that again. The CLI is great, but it's it gets complicated once you start putting a Python wrapper around it. We want to provide variable injection, we want to do attribute lookups, we want to do logging, we want to handle errors. That requires some work to actually create that, which we did. And we called this from a notebook or from a GitHub action workflow. We're now using the Python SDK to actually test what we're deploying, as of course we always will. But the SDK is much simpler, and we're going to talk about that next. So basically, we have the AWS CLI, we have Bolto 3, which is the Python SDK for AWS. We have I don't see my notes, but we have other libraries which provide us with the SDK to Databricks. I think it's just Databricks SDK. Using the CLI, we need to make multiple REST calls, right? So for example, if we want to know what clusters we have to do a clusters list, and then we have to do a clusters get on each individual cluster to get that more detail, and manage all of those functional calls within our Python wrapper. However, with the Python SDK, it's much simpler. We just make a single call, and we can get not only a list of what clusters we have, but also all the details involved in how many nodes they have, what the driver node is, this sort of thing. So it's much simpler all around. So my suggestion to anyone that is contemplating the same path as we took would be to jump right into the SDK. It's now out of public preview, general release. The documentation is way better. There's still some challenges sometimes, but overall it is a much more path to productivity is going to be much faster than it is trying to do something with the CLI. We still use the CLI for things, as we'll talk about in a minute. So pipelines is okay. Interesting. Anyway, the last piece that I want to talk about, we've talked about infrastructure as code, about deploying the actual platform that we're going to deploy to our end users. That's all really important. They can't work without it. But the next level beyond that is the actual work that they're doing within Databricks, right? And obviously, when they create notebooks and this sort of thing, they're checking that into Git, and we have that within our repo, and we can sync that with a future workspace, whatever else. But they're also creating artifacts like pipelines. And prior to Databricks asset bundles, which we're talking about now, it was much more complicated to deploy our pipelines. But now DABs were released last year, 2023, at the Databricks Summit, and they enable us to apply software engineering best practices to pipelines within Databricks. We started using them a little bit trepidatiously, but they actually work really well. So in this diagram, really briefly, we have this is our Metastore that we've been talking about. We have our three environments, prod, dev, test, and dev. Our source code and is basically obviously created within dev. We're also creating our workflows as YAML within dev as well, checking those into our repo. And then this is basically just showing our GitHub actions for promoting data from dev to test to prod. Don't worry about the arrow directions, that's dependencies. The actual flow will be from dev to test to prod as we elevate these entities through our three environments. Now, the new repo that we're providing here is the second one. It has a DAB promotion code. And basically, this is providing the GitHub actions that we're going to use to pull not only our source code for our workflows, but also this workflow YAML that we're creating to actually glue them all together, and basically building our code representation of our workflow, and then deploying that to the environment. So we can deploy that to the dev environment. That's more around testing. It's not actually really a promotion, but certainly for test and for prod, it allows us to build a workflow in dev, test it, and then as I'll show on the next slide, define who's going to have access to it, how it's going to run, what it's going to do in higher environments, where it will be running as a service principal, of course, and then basically use the CLI within GitHub, within the GitHub Actions pipeline to build that DAB and deploy it to those higher environments. Okay, so it works surprisingly well. Yeah, so a quick example, we're nearly towards the end of what I'm going to cover here, but in this particular case, we have, I'm just giving a really high-level example of a DAB. We have a bundle section that I'm not showing because really it just gives us the name of the bundle and the CLI version. We have permissions where we're telling it, in this case, the name of the service principal we're going to run the pipeline at in test, for example, and what that service principal is able to do. So in this case, it's able to run that workflow or pipeline, sorry. We have a resources section, and in here we define the individual notebooks that we're going to use. These are all actually in a subfolder underneath the DAB. So there's an extra step when we actually deploy this thing, is we need to pull them out of source control and put them into I think it's called source, but I forget, but into a new subfolder where we're going to deploy it from, because the DAB workflow itself does not have access to the source control within the test and the prod environments. So that's kind of an extra step. We also do lookups on cluster IDs and this kind of thing. Here it's a bit simplistic, but we can use REST calls to connect to the Databricks API within Databricks and basically do lookups on cluster names and this kind of thing, which allows us to be ephemeral. Obviously, when we drop a platform and rebuild it, the cluster IDs change, but the names of the clusters don't, so we can do lookups. And then the last section that we're interested in is the targets that allows us to define the environment that we're deploying into. In this case, I've shown dev, but obviously we have another block here that gives us the test and the prod environments, and the service principals could be different. Obviously, the workspace URL is different. Basically, there's a bunch of attributes in here that we can set that allow us to control what's going to happen in each environment when we deploy this DAB. We deploy it through the CLI said, just issuing CLI commands from the CLI that we have pulled into our pipeline, our GitHub Actions pipeline, which we showed in the last slide. Lastly, that all sounds really complicated. How do I know how to build these things? It's actually way simpler than you might think. We can go to our pipeline that we have built manually within our dev environment. We can basically click on these three little buttons. I think it says show job source or whatever else. We can have a YAML view, and now we can take all of this. We can use this as the source to build our DAB from. We obviously have to make changes because now we're going to do lookups on the cluster ID and on the the people who have access to it and this sort of thing, who we're sending email notifications to. I mean, all of these sorts of details. But it's a really good head start into building this pipeline within a code approach within our workspace. So incredibly successful so far for us. We are very happy with how this all came together as far as our ability now to trigger promotion of pipelines and rebuild them on rebuild of our environments as well. So that's pretty much all I want to cover for the presentation. Let's just kind of circle back and just refresh our memories about what we covered. I gave you like the 1,000-mile introduction to Databricks and to Unity Catalog. We talked at some depth about Databricks architecture. We talked about how we access S3 storage from Databricks. Then we talked about infrastructure as code, kind of left the best to last, pipelines as code as well. So that's kind of the details of what we covered. Just a couple of references moving forward. Thank you to the internet for all of the free images that we can pull. We have access to huge amounts of Databricks documentation. I find Medium an incredible resource as far as getting people's interpretations on how to interpret the Databricks documentation. Lots of great information there. And it's always worth circling back to the AI summits. It's where Databricks makes most of its major announcements. I want to thank Yoma the cat for his help with our presentation. And with that, really, we're done. Cats are wiser than us. He's going to go sleep. And that's hopefully what I've allowed us all to do by showing us how we can effectively use IAC principles to build our Databricks environments, both the environment itself and the pipelines and jobs within it. So that's the end of the meeting. I'd like to thank you all for joining us. I am available now for questions. If anybody wants to reach out to me personally or through Improving, they're very welcome to do so. But that's the end of our slides for today.
Thank you, Tom. Very interesting talk. And let me check if we have questions. No, we don't have questions in the Q&A.
Did we have any viewers? That would be the next question.
Yeah, but I think maybe thinking in a lot of information.
There was a lot there. It's always hard to know where to, at what level to provide these presentations. But as I said, we tried to cover a lot of ground. If people have anything in specific they would like to talk to us about, then obviously reach out through Improving, and we'd be more than happy to help.
Okay, but I think that's all. Thank you, Tom. This is really interesting, and thank you all for connecting in this Improving talk.
Thanks, Maurice, for keeping us all on track.
See you soon. Bye.
Thanks.